Ethernet technology provides rules that allow network-connected devices to talk to one another without talking over each other. In a verbal conversation, when two people speak at the same time, each may have difficulty understanding what the other is saying. This is amplified when, say, 10 people are talking at once. Imagine 100 or 1000 at once. The same is true for a data network. If two or more connected devices on a shared network attempt to transmit data packets at the same time, a packet collision occurs. The pulses of electricity or photons that make up a packet overlap when sent at the same time over a shared copper or optical cable. This jumbles the sequence of on pulses and off voids that are sent to indicate the bits and bytes of ones and zeros that make up a packet. Ethernet was designed to solve the problem of packet collision. It provides network devices with a set of rules that essentially says, make sure no one else is talking before you talk. If you hear someone talking while you're talking, stop, listen, and wait for the talking to end before you talk again. Ethernet is commonly associated with connected devices in a wired LAN or WAN. Using a wired Ethernet cable, devices are connected to an Ethernet switch. Ethernet has the ability to use both wired and fiber cables, delivering not only data but also power, now up to 90 W with UPoE+. More formally, Ethernet is a common name for the IEEE 802.3 standard based on the Carrier Sense Multiple Access/Collision Detection, CSMA/CD, protocol. CSMA/CD defines when to transmit and what is to happen if a collision is detected, as well as endpoint addressing, transmission speeds, and media. Ethernet has evolved dramatically since its first application. Today it's the de facto protocol for IP-based networks. The concept of Ethernet has its roots in the late 1960s and the University of Hawaii's Aloha network. Aloha was a pioneering, experimental radio communications network connecting the Hawaiian Islands to a central time-shared computer on the main campus, in Oahu. Aloha was often referred to as one of the first wireless packet networks. It used two radio frequencies, separating send and receive data that passed between user terminals and the main hub connected to the computer. Designed for simplicity, the network followed these rules. Send a packet when you're ready and wait for a receipt acknowledgement. If no acknowledgement occurs, resend at some random time. As use of the network grew, it became obvious that packet collision would severely limit the capacity of the network as designed. Researching the problem for his doctoral thesis, a young computer science student, Bob Metcalfe, devised a solution. His innovation earned him not only his Harvard PhD but a place in history as the inventor of Ethernet. Metcalfe's solution: listen before you talk. In 1972, Metcalfe took Ethernet from idea to fruition with the first experimental Ethernet system, created at Xerox PARC. The network had an initial speed of 2.94 Mbps and linked Xerox Alto's mainframes, servers, and printers using inexpensive coaxial cable. At the time, Ethernet competed with Token Ring, ArcNet, Fiber Distributed Data Interface, FDDI, and other proprietary protocols. It quickly rose to dominance as it was open and reliable, yet inexpensive. Today, it supports speeds from 1 Mbps to 400 Gbps and beyond. Ethernet was formalized in 1983 as the IEEE 802.3 Ethernet standard. It is one of 12 in the IEEE 802 family of variable-size packet LAN standards. IEEE 802 services and protocols focus on the physical and data link layers of a network. In the Open Systems Interconnection, OSI, networking model, those layers are known as Layer 1 and Layer 2, respectively. Based on the addressing scheme used in early implementations of Ethernet, the IEEE 802 standards use Media Access Control, MAC, addresses, which are unique identifiers typically assigned to endpoint access hardware by device manufacturers. The most significant part of a MAC address identifies the manufacturer, which assigns the remainder of the address, potentially providing a unique address. This makes it possible for frames to be delivered within a network that interconnects sender and receiver through some combination of Ethernet switches. Routers are used to pass packets between networks and use IP addresses rather than MAC addresses to tag packets' origination and destination points. Using the U.S. Postal Service as an analogy, IP addresses are like zip codes, while MAC addresses are like street addresses or post office boxes. In an Ethernet network, data is broken into packets, with each packet transmitted using the CSMA/CD algorithm until it arrives at its destination without colliding with any other packet. The first open slot after a transmission is reserved for an acknowledge packet. A device or node is either transmitting or receiving at any instant. When sending data to another device on an Ethernet network, the MAC sublayer, data link sublayer, encapsulates higher-level frames into frames appropriate for the transmission medium. Adds a frame check sequence to identify transmission errors. Forwards the data to the physical layer as soon as the CSMA/CD protocol permits, waiting as necessary to avoid collisions. Is responsible for compensating for collisions by starting retransmission when a collision, jam signal, is detected. When receiving data from the physical layer, the frame check sequence in the MAC block is used to ensure data integrity. It strips off the sender's Ethernet packet preamble and padding before passing the data to the higher layers. The Ethernet switch creates the frame by encapsulating the Ethernet packet with a preamble, which is used to synchronize the sender and receiver, followed by a 1-octet start frame delimiter byte. The Ethernet packet includes the data encapsulated by a header and a frame check value. The MAC header provides the source and destination MAC addresses as well as a 2-octet Ethertype code indicating IPv4 or IPv6, MACsec encryption, etc. The frame ends with a frame check sequence, FCS, which is a 32-bit cyclic redundancy check used to detect any in-transit corruption of data. When a frame is ready, the transmitting station checks to see whether the channel is idle or busy. If the channel is busy, the station waits until the channel becomes idle. If the channel is idle, the station starts transmitting and continually monitors the channel to detect collision. Ethernet is defined as a networking technology that includes the protocol, port, cable, and computer chip needed to plug a desktop or laptop into a local area network, LAN, for speedy data transmission via coaxial or fiber optic cables. This article explains the meaning of Ethernet and how it works, along with its key uses. Ethernet is a communication technology developed in the 1970s by Xerox that links computers in a network via a wired connection. It connects local area network, LAN, and wide area network, WAN, systems, WAN. With LAN and WAN, several devices, such as printers and laptops, may be connected across buildings, residences, and even small communities. It provides a straightforward user interface that facilitates the connection of several devices, including switches, routers, and PCs. With a router and just a few Ethernet connections, it is possible to construct a local area network, LAN, that enables users to communicate between all connected devices. This is because laptops have Ethernet connectors, into which cables are inserted, and the other end is linked to routers. Most Ethernet devices are compatible with Ethernet connections and devices that run at slower speeds. However, the connection speed will be determined by the weakest components. Wireless networks have superseded Ethernet in many locations, yet the latter continues to be more prevalent for wired networking. Wired networks are more reliable and less susceptible to interference than wireless networks. This is the primary reason why so many businesses and organizations continue to adopt Ethernet. Ethernet celebrated 25 years of existence in 1998. By that time, it had undergone several revisions as technology advanced. Ethernet is continually redesigned as its capabilities expand and evolve. Today, it is among the most widely used network technologies worldwide. Ethernet was created in the early 1970s at the Xerox Palo Alto Research Center, PARC, by a group that included David Boggs and Robert Metcalfe. In 1983, the Institute of Electrical and Electronics Engineers, IEEE, ratified it as a standard. Metcalfe developed the idea of Ethernet in a document he wrote for Xerox PARC in 1973, marking the beginning of Ethernet's development. Metcalfe built Ethernet based on the Aloha system, an earlier networking initiative that started in 1968 at the University of Hawaii. Metcalfe determined in 1973 that the technology had surpassed its initial appellation, Alto Aloha Network, and rebranded it as Ethernet. Metcalfe and Boggs, together with their colleagues at Xerox, Charles Thacker and Butler Lampson, would successfully trademark Ethernet technology 4 years later. In 1980, Xerox collaborated with Digital Equipment Corporation and Intel to create the first 10 Mbps Ethernet standard. And in the meantime, the IEEE Local and Metropolitan Area Networks, LAN/MAN, Standards Committee set out to produce an equivalent open standard. The LAN/MAN Committee established an Ethernet subcommittee with the designation 802.3. The IEEE adopted the first 802.3 standards for thick Ethernet in 1983 and was published formally in 1985. The Ethernet protocol employs a star topology or linear bus, which is the basis for the IEEE 802.3 standard. In the OSI network structure, this protocol works BOT-H, the physical layer, and data link layer, the first two levels. Ethernet divides the data connection layer into two distinct layers, the logical link control tier and also the medium access control, MAC, tier. The data connection layer in a network system is primarily concerned with transmitting data packets from one node to the other. Ethernet employs an access mechanism known as CSMA/CD, Carrier Sense Multiple Access/Collision Detection, to enable each computer to listen to the connection before delivering data across the network. Ethernet also transmits data using two components, packets and frames. The frame contains the sent data payload as well as the following: both the MAC and physical addresses of the sender and recipient. Error correction data for identifying transmission faults. Information on virtual LAN, VLAN, tagging, as well as the quality of service, QoS. Each frame is encapsulated in packets that comprise many bytes of data to set up the connection and identify the frame's commencement point. An Ethernet connection encompasses the following. The Ethernet protocol. This protocol was developed in the 1970s by Xerox. It is a series of standards that governs how data is sent between Ethernet components as explained before. The Ethernet port, Ethernet ports, commonly known as jacks or sockets, are openings on computer network infrastructure into which one may plug in Ethernet cables. It supports cables with RJ45 connectors. The Ethernet connector on the majority of computers serves to connect the equipment to a wired connection. The Ethernet port of a computer is linked to an Ethernet network adapter, also known as an Ethernet card, mounted on the motherboard. A router may contain numerous Ethernet ports to support various wired network devices. Ethernet network adapter. An Ethernet adapter is a chip or card that fits into a slot on the motherboard and allows a computer to connect to a local area network, LAN. In the past, these were always used with desktop computers. Ethernet is now integrated into the chipsets of laptop and desktop motherboards. An Ethernet cable, often known as a network cable, links your computer to a modem, router, or network switch. The Ethernet cable consists of the RJ45 connection, the internal cabling, and a plastic jacket. Uses of Ethernet. Improves consumer internet experiences. When their wireless Wi-Fi data connection speed is insufficient, many in their homes deploy Ethernet connections. Ethernet is typically used to link several devices in a local area network, LAN, and a wide area network, WAN. Offers high bandwidth connections. Ethernet offers data transfer rates of 10, 100, 1000, 10,000, 40,000, and 100,000 megabits per second, Mbps. When Ethernet was originally created, bands were defined in megabits per second, Mbps, but they are currently calculated in gigabits per second, Gbps. Provides different options of speed, Based on budget, region, and requirements, standard Ethernet's top speed is 10 Mbps, whereas fast Ethernet's is 100 Mbps, Gigabit Ethernet's is 1 Gbps, while 10 Gigabit Ethernet is 10 Gbps. Strikes a balance between cost and performance. Ethernet is widely used due to its affordable price and compatibility with any subsequent network device. Ethernet speed was approximately 10 Mbps in 1983 and now exceeds 400 Gbps. Ethernet is extensively used by companies, hospitals, schools, universities, and gamers due to its fast speed, network security, and dependability. Amplifies the capabilities of your Wi-Fi network. In recent years, Wi-Fi has become increasingly popular. Wi-Fi has improved speeds and offered extensive coverage due to technological improvements. Wi-Fi transmissions can only simultaneously support a limited number of devices. In older buildings with frequent Wi-Fi dead zones, Ethernet connections are essential. Enforces greater security. Ethernet has the advantage of being more secure than Wi-Fi. Anyone within a Wi-Fi hotspot's range may access data transferred over the radio. Because radio signals deliver the information, it is vulnerable to theft. In contrast, data supplied by Ethernet can only be accessible on the local area network. Supports direct current, DC, power transmission. As its name suggests, Power over Ethernet, PoE, is the provisioning of energy supply over Ethernet connections. It powers many devices, including CCTV cameras and wireless access points. One of the primary advantages of power over Ethernet is that a distinct power source is unnecessary. This is especially useful for placing devices in locations that are far from the nearest power source. Thank you for watching this video.